Last episode, we created a big plan with multiple fixes, how we could get our performance to the maximum. Now we have a couple of points and I want to test them out, how they behave and what is the impact for the performance. And namely, we have AsNoTracking, response compression, cancellation tokens, command timeouts for the entity framework, and we enforce pagination for the maximum page size. So let's go one by one and see what do they mean, what do they do, and what are our options. Tracking behavior controls if entity framework core keeps information about an entity instance in its change tracker. If an entity is tracked, any changes detected in the entity are persisted to the database during save changes. Core also fixes up navigation properties between the entities in a tracking query result and the entities that are in the change tracker. So in short, Entity Framework Core is tracking all the changes in its state machine and needs to know which entities has changed and which hasn't changed. And to turn it off, if we don't need to track the entities for its state, it's pretty simple. We can just simply turn it off by stating AsNoTracking. Or we could also turn it off globally, this no tracking, and it will result that any kind of changes for the entities that we retrieve from the database will be not updated. So there will be no accidental, updates. So let's take a look on the response compression and let's see what Microsoft is saying about it. So network bandwidth is a limited resource. Reducing the size of the response usually increases the responsiveness of an app, often dramatically. One way to reduce payload sizes is to compress an app responses. When to use response compression middleware? Use server-based response compression technologies in IIS, Apache, or Nginx. The performance of the response compression middleware probably won't match that of the server modules and don't currently offer built-in compression support. Use compression middleware when the app is unable to use the following server compression technologies. So when we do not use IIS, Apache, or Nginx, we should use it. Or when we are hosting on HTTP sys server or the Kester server. So in our case, we do not use Nginx or IIS and so on. And we do use Kestrel. So yeah, it does make perfect sense for us because we are hosting this locally and we do not use any server like these. Let's talk about cancellation tokens on async calls. It's pretty simple. When we have any handle to external resource, such as database, we should dispose it as soon as possible when it's not needed. And also, whenever it has failed, I want to exit as soon as possible. So in our case, we didn't have it and we should have it. So that's pretty simple. For Npgsql command timeout, I also want to exit, and this is pretty much connected with that, but I don't want to await those calls so long in case they have hang on the database. So I don't want to wait for 1 hour when I can exit this for after 30 seconds or 10 seconds, right? And lastly, enforce pagination max page size. In this case, this is really important to not send a 10,000. It's important to not send 10,000 items at once to the client because probably he doesn't need this, and we also do not want to send such a gigantic number of items to the client because probably nobody needs that, and also it will kill the CPU, right? Let's see in the code how it looks. So we have a couple of things here. We have here Pagination, which we talked about, which has maximum page size of 200. We have AsNoTracking, which will disable our tracking of the entity because we are in the reading endpoint. And what else we have here? We have also cancellation token, which is passed from the dispatcher. And also we have applied the pagination here with the skip and take pattern. And also in here, during toList materialization of the query, we are also passing the cancellation token. So it will ensure that our query will not be hanging forever, or it will just cancel and will throw an exit in the moment when the error occurs, right? So yeah, that's the one thing. And another one is the response compression and add response compression and use response compression, and such easy way we implemented those changes. So pretty simple. And let's see what are the results. Previous one was looking like this. It was around 2000 requests, and current one is oscillating around 3100 requests. So we can see really easily that the reading has improved significantly. Let's zoom out and let's see all the 4 requests. We can see that's the best lap so far, and we went from this level. So we went from 16, 17, 1800 requests per second to 3100 requests per second. So great improvement. For writing, I was expecting that it will not improve anything when it comes to requests per second. We should compare this. So we should compare this purple to this orange. So it was previously around 2800 and now it's 2550. Yeah, it's a little bit worse, but we can see a significant improvement for reading. And last part, which is really important. Previously, I was thinking about the limit, the hard limit of the 300 milliseconds for response time for each reading and writing. It was 500, and now I'm thinking about 300 because we will need to go higher and higher when it comes to number of virtual users, because this is also one of the takes. Previously, we went to 600 virtual users and we were maxing out the response times here. And we were only on the 600 virtual users. Right now, we can easily go to 1,000 virtual users. Actually, we are timing out 1,000 virtual users. So it will mean when we will go higher, we need to have a room for the CPU to actually send so many requests, right? For instance, when we will have scaling, I expect to have more and more requests, and my computer needs to send somehow so many requests, right? Yeah, so response time for writing, that's the last part, which I want to mention. Yeah, it's the same. It's the same for response times for writing. And another piece, I also increased the virtual users to 1,000. So that's why you can see a little bit more data sets, data points here. So that's really awesome. That looks that we went from 600 virtual users to 1,000 virtual users for 300 milliseconds response time. And we went from 2100 RPS to 3100 RPS. So it's a great achievement. So if you liked it, let me know. Subscribe and share or comment and like it, whatever you want to do. And if you want to see more, let me know. And see you next time. Thanks.